Hey students, this is lesson 8.4, multiplying special cases. We're going to find the square of a binomial and find the product of a sum and a difference. And kind of look for some shortcuts for doing this. You can use the same strategies we used on 8.3 to find the answers, but knowing these shortcuts actually gives you a little bit more number sense when you're doing certain kinds of multiplications. So anyway, go ahead and do the vocab here and you can check back for your answers. All right, here's an example, key concept. We're going to learn how to square binomials, and actually, just let me give you a quick little example of what's going on here. Let's say we have something like this, 3x plus 5, and we want to square it. Or maybe we have something like this, 2x minus 7, and we want to square that. Well, using our table, our times table, what we really have is this, 3x plus 5 and 3x plus 5. And what we end up with is 9x squared here, and 15x here, and here. So we really have 15x doubled. And if you think about that, 15x comes from this 3 times this 5. 3x times 5x is 15x, and then we just have to double it because that occurs twice. And so we end up with 9x squared plus 15x twice, which is 30x, plus 5 times 5 is 25. Now, if it's a subtraction, kind of a similar situation happens. So we have our times table. The only thing is we have a negative 7 here and a negative 7 here. Well, 2x times 2x is 4x squared, and you get that by just multiplying that by itself. Negative 7 times 2x is negative 14x, and we have that same product down here, negative 14x. And then negative 7 times negative 7 is 49. So what we have is this number multiplied by itself, which is 4x squared. We have 2x times negative 7, which is negative 14x, but we have that twice, so that makes negative 28x. And then we have negative 7 times negative 7, which is positive 49. So if we have a binomial squared like this, we can shorten that process by thinking about this. Take the first number squared for the first term, take the last number squared for the last term in the trinomial, and then for the middle term, just multiply each of the two terms by themselves and then double it. And if it's a minus, it's exactly the same, only instead of a plus 2ab, it's a minus 2ab. So, so to do this problem, we're just going to do the first term squared, x squared. And for the last term, we're going to do negative 7 multiplied by itself, which is 49. And for the middle term, we're just going to take x times negative 7, which is negative 7. X and double it, which makes negative 14x. For this example, we can take x squared, 9 squared for the last term. For the middle term, we can just do x times 9, which is 9x, and double it makes 18x. All right, so the simplified form here would be, and if you want to pause and check back with your answer, which you certainly can do, pause now. So we're going to take the first term squared for the first term in our trinomial. The last term in our trinomial is going to be 5 squared, which is 25. And the middle term is going to be x times 5, which is 5x, and then double that makes 10x. And we get our answer. So 3n multiplied by itself, 3n times 3n is 9n squared. Negative 1 multiplied by itself is positive 1. In the middle term, we're going to take 3n times negative 1, which is negative 3n, and double it makes negative 6n. All right, you can go ahead and try it. Check back with your answers. All right, so we can use that idea to solve some problems. Here, what we end up having is a square inside a square, and we want to know the area of the shaded part. And what we can think about is, what if we got this area of the whole great big square with the dimensions x plus 5 and x plus 5, and then we subtract the area of the smaller square, which has dimensions x times x. So what we really have to do here is square this binomial to get the area of the large square, then square the side length of the smaller square to get that area and subtract the 2. So let's use our shortcut now. If we multiply this binomial, we get x squared for the first term. The last term of the trinomial is 5 squared, which is 25. And then the middle term is x times 5, which is 5x, doubled makes 10x. And then we just need to subtract x squared. And notice we have x squared here and x squared here. X squared minus x squared is 0x squared, which is 0. So we end up with just 10x plus 25 for our final answer. I'll let you go ahead and try that. All right, let's see how we can use this to do some mental math here. When you multiply 49 times 49, what you're really doing is 4 different multiplications. Some of them are duplicated though. And if we think of 49 as a binomial, and I'm going to pick this one, and you'll see why in a second, but let's call 49 50 minus 1 squared. Well, now think of this as your A and your B, so we really have this, A squared, A minus B, 1B squared equals A squared minus 2AB plus B squared. And my A is 50, and my B is 1. Negative 1, actually. So I really need to do this, 50 squared minus 2 times 50 times 1 plus negative 1 squared. And if you think about that, that's just 2,500 minus 100 plus 1. So it's just 22,401. And a lot of that is just pretty simple math, like 50 times 50 is 2,500. You can do that in your head. 50 times 1 is 50, and double that is 100. So you have 2,500 minus 100. And then you just need to add 1 to get 2,401. Now you could also do it this way, but I think this would complicate it a little more. We could think of it as that. Well, now you would have 40 squared, which is 1,600. Then 40 times 9 is 360, and double that would be 720. You could probably do that in your head. That's 2,320. And then 9 squared is 81, which ends up with 2,401. But using the numbers 50 and 1 are a little bit easier. So go ahead, you try it here. All right, another thing we have is we have a product of a sum and a difference. Something interesting happens here, and let me give you just a quick example of that. What if we had something like this where we had binomial 2r minus 5 and another binomial 2r plus 5? Well, if we set up our table here and we write these in, we have a minus 5 here and we have a plus 5 here. Look what happens. This is 4r squared. This is negative 25. But 2r times negative 5 is negative 10r, and 5 times 2r is positive 10r. And when we add those together, they're going to equal 0. So we're just going to end up with 4r squared, which is this number times this number, and then minus this number times this number. And let's just see if that happens in all cases. Like let's say we had, I don't know, 8 minus r times 8 plus r. We put that in the table. And we do minus r plus r, and we multiply that 64. Notice again, this is negative 8r, this is positive 8r, and those two added together are going to be 0, so we end up with just 64 minus r squared. So we just found a case which is kind of rare, but where when we multiply two binomials, we actually get a binomial, and that's because the two middle terms, or the outers and the inner, if you're using the FOIL method, cancel each other out and equal 0. So here's an example. And notice the minus 6r and the plus 6r make 0, so we just get r squared minus 36. If we can remember that, we can just take our x's and multiply them together. Take our 2's, multiply them together, and then subtract. And here is the property. So let's try that once here. It looks kind of complicated, but if we notice that we have the same number here and the same number here, and one is a subtraction and one is addition, we're going to get that situation where we get opposites and they add together and our middle term ends up being 0. So we can just take x squared times x squared, which is x to the 4th. And we can take 6 times 6, which is 36, and subtract that. And you can always use your FOIL method or whatever to do this. It's just that this is a shortcut that can kind of help you out. So if I do my first two terms, I get x squared. If I do my outer terms, I get plus 6x squared. That should be x to the 4th, sorry about that. If I do my inner two terms, I get negative 6x squared. And if I do my last two terms, I get negative 36. But when I simplify, that part equals 0. So go ahead, you try that. All right, so we can use that idea if we have a minus b times a plus b to do a little, help us do some mental math. So remember, we get a squared minus b squared when we do that. Well, notice this is exactly 2 less than 40, and this is exactly 2 more than 40. So I can really write it like this. And now, since we have the exact same number there, the exact same numbers there, just one is subtraction and one is addition, we can just do our a squared minus b squared. So 40 squared minus 2 squared is our answer. 40 squared is just 1600, and 2 squared is 4. And you could do all that in your head, so you can do a multiplication like this in your head pretty quickly. All right, go ahead, you try that. All right, lesson check. What rule would you use to find the binomial squared, 3x minus 1, and why? This is a square of a binomial, and the rule would be right here. And to simplify that, I would just do 3x multiplied by itself, which is 9x squared. Then I would do 3x times negative 1, which is negative 3x, and double that to get negative 6x. Then I would just do negative 1 times negative 1, which is positive 1. The rule I would use for this is a minus b times a plus b is equal to a squared minus b squared. The rule I would use for this is a plus b squared is equal to a squared plus 2ab plus b squared. All right, that's the lesson. See you tomorrow.